Let's take a closer look at earthquake size and earthquake distribution. Hopefully you've already tried pages 99 and 100 in your lecture tutorial before you watch me give you the answers. So in each situation, you're supposed to circle which would give more damage and a higher intensity. And remember that intensity describes damage in a particular location. So small magnitude earthquake versus large. A large magnitude earthquake is going to give you greater intensity, greater shaking. What about building codes? Well, poor building codes are going to result in more shaking and more damage. What about the location of the earthquake? Well, earthquakes that are near Earth's surface are going to affect the surface more than deep earthquakes. Building on soft sediment versus stable bedrock is a big problem. Soft sediment does not provide a good foundation for buildings. If you're located close to the earthquake, then you're undoubtedly going to have more intense shaking than if you're far from the earthquake. And finally, if there are a lot of buildings and structures, those are more likely to produce damage than if you just have a few buildings. Two students are debating intensity and magnitude. Student 1 is correct. Intensity varies depending on location, but a given earthquake has only one magnitude value. For example, there could be a magnitude 6 earthquake in San Francisco. The intensity of shaking is going to change as you move away from the epicenter and probably become less and less. But no matter where that earthquake was measured, it's still going to come up with a magnitude 6. Speaking of San Francisco, there was a rather large earthquake in 1989 called the Loma Prieta earthquake that caused a lot of damage. It asks you to explain why the Loma Prieta earthquake had a high intensity. There are several reasons. As it says in the description here, the buildings were built on soft sediment. And soft sediments are less stable than building on solid rock, so building foundations are more likely to fail. Earthquake shaking is also amplified in regions that have soft sediment versus hard bedrock. Finally, earthquake shaking can cause liquefaction. This is when the sediments basically get shaken and surrounded by groundwater, and they lose their strength, and things just sink right into the ground. This question asks you to give some reasons why the largest magnitude earthquakes might not necessarily be the deadliest. And here are 3 reasons. If the earthquake is very deep, then there's going to be less damage at the surface. An earthquake 20 miles below the surface versus 250 miles below the surface is obviously going to produce a different result at the surface. The earthquake might be located in a remote region far from population centers. A third reason might be the building code. Buildings that are constructed to withstand earthquake shaking are going to do much better when it comes to shaking from earthquake waves. If earthquakes of the same magnitude happen in California and Haiti, we would not expect them to have the same intensity, and the main reason again is the building code. Most buildings in Haiti are not strong, and they're not built to withstand shaking. On the other hand, California has strict building codes. All new buildings must be able to withstand earthquake shaking, and old buildings have to be retrofit to make sure that they can handle shaking that might occur. Moving on to earthquake patterns, the next 2 pages in your learning tutorial. If you haven't done these on your own yet, pause the video and try them before you see the answers. Looking at this map, do all earthquakes occur on the coastlines of oceans? No. Give an example. Well, if you look at the Atlantic Ocean, and I'm going to highlight it in pink, there aren't really any earthquakes along those coasts. Do earthquakes only occur along coastlines? Well, that's not true either. Look in the Pacific Ocean, and I'm going to mark these with yellow. All of these earthquakes are in the middle of the ocean, and they're not near coastlines. Do earthquakes occur just in hot climates? No, they certainly don't. An example is looking near the poles. I've put these in blue. These are earthquakes that are near the North and South Pole. Why do earthquakes occur where they do? Because they occur along active plate boundaries. 2 students are debating about why more earthquakes occur in California than New York. It turns out both of these students are correct, because California has active faults, which are directly the result of its location on a plate boundary, and earthquakes occur along active faults. Here's a map that shows various locations. Based on these locations, which ones are least likely to experience earthquakes? Well, that would be C, D, and E, because they are far from a plate boundary. Do all locations on coastal communities experience earthquakes? No. A and B are along the coast because that is where the location of a plate boundary is. D and E are on a coast, but they're not experiencing earthquakes, again because there's no plate boundary. Do warm areas more commonly experience earthquakes than cold areas? No. Earthquakes are not related to weather or climate. They're related to the location of plate boundaries. Now you may think this is kind of a silly question, but really there are people who believe in earthquake weather, that the weather is right for an earthquake, and that's just simply not true. Explain to a friend why some places in North America get more earthquakes than others. Again, it has to do with plate boundaries. North America has major plate boundaries along its western margin, so earthquakes are common. There are no active plate boundaries in central or eastern portions of North America, so earthquakes are uncommon, although they do occur. Coming up next, some topics that were not covered in the last earthquake video: earthquake hazards and earthquake predictions.